Hi, everyone, and welcome to Valley of Depth, a podcast from Archaea Media. Archaea builds media brands around the critical technologies shaping national security. We do this through Payload, which covers the space industry, Ignition, which covers nuclear energy, and Tectonic, focused on defense tech, through journalism, events, and original research. With Valley of Depth, we're going deeper, talking to founders, investors, policymakers, and military leaders who are building and shaping some of the most complex and consequential technologies in the world. Today, I'm joined by Blake Scholl, founder and CEO of Boom Supersonic, a company aiming to bring back commercial supersonic travel for the first time since the Concorde. We talk about why the US banned supersonic flight over land in the 1970s and why that's finally changing, the technical and political battles ahead, and Boom's plan to build a sustainable airliner from scratch. We also dig into the business case for supersonic, why this isn't just a luxury for the elite, and why Blake believes supersonic travel is critical for the future of US national security. Before we dive into today's episode, a quick word about Payload Pro, our premium subscription for deep dive space industry insights, analysis on trends, and exclusive research you won't find anywhere else. Each week, we go beyond the headlines with original reporting, investor perspectives, and detailed financial models. Recent topics include SpaceX's projected 2025 financials, Kuiper's business economics, and the resurgence of satellite manufacturing. We also just published our first report, The Case for Space, a 50-page investor's guide to the space economy. If you're in the business of space or just want to understand it like an insider, subscribe now at pro.payloadspace.com. That's pro.payloadspace.com. Blake, welcome to the show. Great to see you again.
Mo, good to see you as always.
I know you are in a particularly good mood these days, so let's start with the news. So the U.S. government just ordered the FAA to repeal the 1973 ban on civilian supersonic flight over land. So what does this mean for you? Let's start there.
Well, it's about time. In 1973, we had what I think is one of the dumbest regulations ever in regulation, where we banned supersonic flight in the U.S. What that means is we banned what would have been the minimum viable supersonic jet. It created 50 years of no progress in flight speeds. And I think the actual truth is worse than that, because when you can't innovate anymore, great people don't even want to work in the industry.
Right.
And so I think there is I don't think it's the only story or the only narrative, but I think it connects very much the ban on supersonic flight and the gradual death of Boeing because there's an entire generation of great young people that went to work in Silicon Valley, not in aerospace. And so the good news is that's over,
right,
and we can innovate again. And that means, when I started Boom 10 years ago, we weren't planning to be able to change the regulation right away. So our focus was on speeding up international travel, doing transatlantic flights in 3.5 or 4 hours, doing trans-Pacific flights in 5 to 8. But now we can speed up coast to coast as well. And with the boomless cruise technology that we demonstrated earlier this year, we know we can fly up to about Mach 1.3 over land with no audible boom. And so that means you can leave New York at 9 a.m. and land at San Francisco at 9:30 a.m. It's going to be awesome.
Yep. No, that's what 2.5 hours of savings. I think it's usually about 6, and now dropping to 3.5. So obviously pretty significant. Before we jump into all of that, I want to talk a little bit more about this regulation or this shift. I'm not saying that all, clearly the regulators have something in mind. I'll say this. Clearly the regulators have something in mind when they come up with a piece of policy. What was the thought process between the 1973 regulation? Why did it even exist in the first place? From your perspective?
Nominally, this was about protecting the public from bad sonic booms.
Yep.
But a thing I've come to believe is most bad regulations have a moral cover story that sounds plausible and something you can buy into. And then there's a real story behind the scenes that's far more sinister. And I think to understand that here, you have to look at the chronology. So in the 1960s, we went from really an entrepreneurially commercial first model of innovation to a national prestige Cold War era model of innovation. So we did Concorde and Apollo. And just like there was a space race to the moon, there was a supersonic race that was a contest between nations. And in America, the FAA spec'd what was called the SST and gave the contract to Boeing to build it. That was a Mach 3, 300-seat airplane. Made no sense economically. Then in Europe, France and Britain got together to do Concorde, 100 seats, Mach 2. Also didn't make much sense economically. And then in Soviet Russia, there was the Tu-144, which is also a 100-seat Mach 2 class airplane. Didn't make any sense economically, but they were communists. They weren't focused on economics. And then what was
and you can maybe come back to this, but your comment on why it did not make sense economically, if you could touch on that, just like what was the driver that just like ultimately, I mean, the Concorde flew for 27 years, right? So like, yeah, maybe talk about that.
Yeah, so this is Econ 101. There's a 100-seat airplane with 100 uncomfortable seats, and tickets adjusted for inflation are $20,000 round trip. You can't, especially with like 1970s, 80s, 90s kind of travel volumes, you can't find 100 people who want to drop 20 grand to go somewhere real fast. It makes no sense. The more expensive the fare, the smaller the market. If it had been a 15-seat airplane for, private use, that would have worked. But 100 seats, $20,000, economically, that's a no man's land. You can't fill the seats. No one's willing to pay the prices.
Right.
So what happened was the American competitor to Concorde was like over budget, behind schedule, like hemorrhaging money. And I think in America, we were sort of ambivalent about whether it really made sense for government to pay for a nominally private development program. So Congress pulled the plug on the American competitor to Concorde in I think 1971, and then all of a sudden it was like we can't have that supersonic stuff, and so nominally it was about the moral cover story was there are these awful sonic booms, they're going to break windows, they're going to wake up sleeping babies, blah 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 blah. It's mostly bullshit, but that was the moral cover story, and I think the real story was Concorde was still coming. It hadn't entered service yet. The world had not sort of internalized how economically dead on arrival Concorde was. And so we had to block it. And it should have been a noise limit, but instead it was a speed limit. And, my most conspiratorial theory of this is the reason it was a noise limit, not a speed limit, speed limit, not a noise limit, was had it been a noise limit that was reasonable, Concorde would have passed. This was national prestige plus industrial protectionism.
Right.
But it was really the greatest own goal in regulatory history. Because what we left is for, Europe never had a supersonic ban. But China never had a supersonic ban. And so we created 50 years of stasis. This is part of the unwinding of American industry. And we created a world where, China now has had 50 years to catch up, and they're building a supersonic passenger jet. So thank God, or thank President Trump, that we've gotten out of our own way here. And I think it's just in the nick of time.
So what's the practical next steps after this, right? So there's an order that says, okay, we need to repeal this ban. I assume it's not just going to be, okay, like everyone go at it, supersonic flight all over land. There's probably going to be some guardrails, I assume. Like, what do you think that looks like?
Yeah. So what the executive order basically says is FAA strike the speed limit and do the common sense thing, make it a noise limit. And the noise limit has to be reasonable. It has to be focused on economic viability, what's technically achievable, et cetera. And so I think, there will be lots of conversations at FAA and kind of how to work out the details on that. But, my expectation is that there will be, an obvious first step, which is boomless supersonic flight should be allowed. And that clears everything up to about Mach 1.3 under the right weather conditions with the right software to control the flight trajectories. And then above that, there will be a sonic boom, and we'll have to figure out how we distinguish between sonic booms that are no big deal and sonic booms that are like actually too annoying. So, if you fly supersonic 50 feet over the ground, yes, you can break a window. There's a great Mythbusters episode on that. They had to try really, really hard to get it to break a window, but it is actually possible. But by the way, if you fly a supersonic passenger jet 50 feet over the ground supersonically, the broken window was not the thing that went wrong that day.
Right.
So, and we got to remember here, there's an inverse square law. So you double the distance to the ground, you get a quarter of the intensity of sound. So I think what we'll find is that high altitude booms from reasonably sized airplanes are kind of no big deal. And also that we'll have ways of kind of shaping airplanes that kind of spread out the energy a bit more, make it quieter. And the FAA will have to figure out where they draw a line on that. But the obvious thing is if there's no boom, it's okay. So I'm incredibly excited here. I think there's more work to be done and kind of working out, dotting the I's and crossing the T's and finding the right words to put in there. And, we're going to get involved and, help FAA do that. I'm sure others will as well.
How long, what is your most optimistic take on how long it takes before we see something, real on the table?
I don't know. It's, I don't think it's going to be the thing that delays us. And actually, fun fact, Boom has never had to wait on FAA. But if you engage with regulators early, if you build trust, if you show your plans as you go, if you say, hey, give us feedback, help us figure out how we make this compliant, help us figure out how we make this safe, then the regulatory relationship is a check and balance. It's fundamentally cooperative, not adversarial. And that's the approach we've always taken at Boom. We've never had to wait on the FAA. When we went for certification for our XB-1 airplane, the FAA saw it when it was a drawing. They saw it when it was a bucket of parts. They saw it when it rolled out. They saw it when we were ready to fly it. And and we said, okay, we think we're ready. And they came and they looked at the airplane and they did a 90-minute inspection and they handed us the paperwork. And that's a process that traditionally, even for an R&D airplane, could take 90 days. So my prediction here is the same. I don't think we'll be waiting on FAA.
Yeah.
But we'll go as fast as we can, and I would love it if that were true.
Right. Let's rewind the clock for a second. Tell us a little bit about why you started Boom. What did you see that others didn't, other than obviously the economic piece of it that you pointed out earlier?
I think that was the biggest thing. A decade ago, the internet was full of mythology about why airplanes didn't go faster. And there are these sort of plausible sounding, but ultimately kind of hand wavy arguments. Like when faster flights are inherently more expensive, people won't pay more. They always want the cheapest ticket. Or unless you solve sonic boom technically and regulatorily, the market's too small, and it's not worth developing a product. And the thing to kind of notice about all of that is those are sort of qualitative claims about quantitative topics. Like, okay, supersonic flights cost more. Well, let's put aside for a second whether that's really true. Let's accept it for a second. How much more? And passengers won't pay more for faster flights? Hang on, don't we pay more for direct flights than connecting? All kinds of people pay to save time. So the question is how much more and what people will be willing to pay for it. Okay, there's not a big enough market without supersonic over land. Well, hang on, run the math. How many passengers are there on what routes? And could you fill an airplane? And so, I said, look, Concorde's operating model in a certain sense worked. Supersonic over water, subsonic over land. They made city pairs like New York, London work, but it was uneconomic because it was too expensive. So how much would you have to beat Concorde by on fuel economy in order to make a supersonic seat with the economics of a flatbed in business class? And it turned out the answer was astonishingly little, like a less than 10% improvement versus Concorde's 50-year-old technology was enough to create a seat with the economics of a flatbed. And at that point I was like, well, that seems possible. And I built another market model and said, well, how much traffic is there on what routes and how big would the market be? And the answer was you didn't have to change the regulations. You didn't have to have sonic boom to see a way of selling 1,000 plus of these things. And so at that point, honestly, for me, it felt a little weird because I'm like the software guy from Amazon and Groupon, and I didn't really see myself as like somehow I'm the human who's going to find the formula that unlocks the supersonic renaissance. But there I was looking at the spreadsheet, and at that, I talked to some people. I tried to find the bug in my spreadsheet. Nobody could find the bug, and I got to a point where I felt like either I have no courage, or I'm going to find the best people I can, and we're going to go make a run at this.
Yep. Well, quick anecdote on your earlier point. I have a couple friends who will literally, they sometimes go to exotic destinations or locations, or I would say less traveled, and they will wait an extra day for a direct flight versus taking a connecting. Like it's like a psychological thing. So they just don't. They're like, we don't do connecting flights. If it's direct or nothing, and we'll wait the extra day to take a direct flight. So I kind of get your point there. Why is now the right moment for supersonic to return? Or should it have always been here? But like, is there anything right now that's going on the macro that tells you like this is like the opportune time to be building a company like Boom?
Yeah. So I think there was a line that got crossed when the 787 entered service a decade plus, 15 years or so ago, because that was when there was now a regulatory approval precedent for all of the technology you need to build a supersonic transport. And so 787 was a big deal here because it was the first primarily carbon fiber composite large commercial airplane. And that is the most important enabling technology for supersonic because carbon composites, they're not just lighter. You can make them in very complex shapes. So you can build an intricately tailored supersonic jet out of composites in a way that's very, very difficult to do out of aluminum. So I think that was really when the line crossed, because that means there was technology that was regulatory approved, and the market with supersonic, with subsonic business class was big enough that you just convert that to supersonic, you get a huge opportunity. So I think that was like kind of the first tipping point. In another sense, the next tipping point was SpaceX, because prior to SpaceX, there was really no example of an entrepreneur starting a private aerospace company and being successful. So that was a huge piece of my inspiration. I was like, hey, this other internet guy went from PayPal to putting stuff in orbit. That sounds harder than supersonic jets. By the way, I don't think it actually is harder. I think the supersonic jet's harder because it's safety critical from day one. But I didn't appreciate that back then. And then if we fast forward to present day, like, boy, we're in the right place at the right time, because we've got a government that believes in American reindustrialization, wants to cut the stupid red tape and get out of the way of American leadership. We've got the technology that's proven on XB1. So, we built the first civil supersonic jet in America. We did the first one made outside of a government or military. We did it for a tenth of the cost anyone else ever has. And now even the perceived red tape blocker is out of the way. So, it's LFG.
Yep. That's it's exciting for sure. There's no doubt. What is the state of supersonic development for commercial use in China? Do you have a sense for what it looks like there?
I think it's early. So what happened was shortly after XB1 broke the sound barrier, suddenly there was an announcement out of China, kind of published in the South China Morning Post, which is the newspaper the CCP uses whenever they want something to be noticed in the West. And it said, hey, we're building a quiet supersonic jet. And then they had this very coarse rendering that I think was out of like someone's like PhD thesis. But the real tell was they said it's the Comac 949. And Comac is the Chinese CCP owned airplane company. And the fact they gave it a model number means they're serious. Now, it's early. Anybody who knows anything about supersonic jets can look at that rendering and they can tell you that's not going to fly. But I think they're going to figure it out. And I think it's game on, but it's also ours to lose. Because we've actually built and flown something. China's shipping a 737 clone. They're working on a 787 clone. This is next. But we still have time to maintain American leadership if we stay out of our own way.
Yeah. Let's talk about your own kind of R&D and your own development, tech development. So you had a relationship and partnership with Rolls-Royce on engine development that ultimately didn't pan out. Can you talk to us a little bit about that, and then sort of your transition into deciding to build the Symphony Engine on your own?
Yeah. So, truth be told, our original plan was to build our own engines. In fact, our first, like my first hire after moving to Denver was a jet engine designer who had worked the Pratt & Whitney F135 and F119, because I thought it would make sense for us to vertically integrate propulsion. And then we sort of got lost on this, in my mind, crazy idea that we could team up with a 100-year-old British company and get them to adapt something, and that would be the lower risk path. And I think that was actually batshit crazy. And and we got down path with Rolls, and we had this technical proposal that sort of worked, and a business proposal that really didn't work, where the engine was going to be this shoehorned, modified subsonic engine. It was going to have not great fuel burn. It was going to have kind of terrible reliability because these subsonic cores were tuned for short bursts of power at takeoff, not long sustained power at cruise, which is what supersonic needs. And then it had all these business model problems. We were going to have to pay $2 billion to develop the thing, and that was the initial estimate. That's going to be optimistic. And it was saddled with the legacy engine business model where the spare parts are marked up 4 or 5x. And if you've got an engine that's not got great reliability and you've got these extraordinarily expensive replacement parts, the economics were just not making sense on this. And so, meanwhile, Rolls had all these other issues, like the CEO got fired. They hadn't announced a replacement CEO. They didn't know what they wanted to be when they grew up. And I was like, this is stupid. We've got all of our eggs in the Rolls basket and it's got a big hole in it. And so we started saying, I actually got very inspired by something that Brian Chesky had said, which she was talking about how he led Airbnb through COVID. And Brian said, when you're in a crisis, you need to be more of who you always are at your deepest core. Go back to who you really are. Don't compromise. And I remember I was sitting in the audience and Brian said that on stage, and I felt like he was talking to me. And I knew what it meant was it was time to dust off the old plans and have the courage to build our own engines. And it was the best thing we ever did. So now we're getting a fully custom engine. The development cost is going to be something like a quarter of what Rolls quoted us. We're going to own all the IP. The engine won't be sold to a competitor, and we can tailor it to match what Overture airliner really wants. And so the airplane, what we know now is not only are we getting a much better engine, much faster and cheaper, we're able to do things with the airplane that the Rolls engine never could have done. This whole boomless cruise thing, we looked at it years ago with a Rolls engine, and it didn't have the transonic performance to actually do it.
Right.
But our own engine can. So
how long? So actually, let's talk about the XB1 flight, right? That you just recently had.
Mm-hmm.
You hit supersonic. You demonstrated boomless cruise. What engine were you using there? That was Pratt & Whitney?
No, it was an off-the-shelf older GE engine.
Okay.
So XB1 was really about the vehicle integration, and we didn't build a one-off engine for a one-off airplane. That doesn't really make sense.
Right.
But we were able to because this engine, the J85s, actually have great transonic performance. We were able to demonstrate boomless cruise the same way we'll be able to do it on the Overture airliner.
And then what is your sort of rough roadmap as to when Symphony, you'll have a working model of Symphony?
End of the year. We're building the first one right now. And I think we've got about 60% of the parts are somewhere in the manufacturing process. We're a couple months away from, starting to put the first one together. And our goal is to make fire by the end of the year. You could slip a little bit into Q1. That wouldn't surprise me if that happened, but we're making great progress. And we're developing that engine. So one of the most interesting things to know here is everything on Overture and Symphony is conventional technology and unconventional development approach. So the way conventional development works is in modern day aerospace is the bean counters have taken over, and they look at these plans that have these things on them called prototypes. And they say, wouldn't the plan be faster and cheaper if we deleted that? And so they delete it out of the plan, and the plan looks faster and cheaper. But it only ever looks better on paper. Invariably, it's never perfect the first time. But what actually happens is the engineers spend an enormous amount of energy wringing their hands, trying not to be the ones that actually made the critical mistake. Then they go build the thing, and invariably it never works perfectly the first time. But then everyone's surprised. Hard tooling has been built, and it's incredibly expensive to fix the problems once everything is fully baked. The history of this is just like everywhere over every modern aviation program. Like the GE engine on the 777X is a down the middle example of this. They deleted all the prototypes along the way, planned to get it right the first time, and guess what? They're humans, they missed. And so this is the most expensive and slowest way to develop. The fast way to develop is to say, let's find a way to vertically integrate hardware such that hardware is inexpensive. We can build it quickly and cheaply. We can take our designs, build them, test them, and then find out what's not right and iterate. And so that's what we're doing on Symphony. And I'll give you a case study, like zoomed in at the micro level. So the first prototype engine is the core, not the full up turbofan, because we're going to go test that part first, then we'll build from there. And we're 3D printing blades that probably won't work for production. We probably won't get the materials properties, but it'll absolutely help us validate turbine aerodynamics. And so we go quote out these turbine blades, the traditional aerospace supply chain, and it's going to take 6 months to get them, and it's going to cost $1 million. And so, Elon talks about what he calls the idiot index, which is the final part cost divided by the raw materials cost. And so the idiot index on these things is like 1,000. $1 million for the finished parts out of like about $1,000 worth of powder metal. But the worst thing is this thing that we call the slacker index. And the slacker index is how long it takes to get something divided by how long it takes to make it. And you can print these blades in like 24 hours. And so but it was taking 180 days to get one. And so that's a slacker index of 180. And I think the slacker index is often more destructive than the idiot index. And because if it takes 6 months to get a set of blades, what that means for engineers is if they get the blade design wrong, we're down for 6 months before they can fix it. So now we're back in that like hand wringing analysis paralysis, can't make a mistake mode. And so what I said is that this is crazy. We got to figure out how to fix this. And my assumption was that the 3D printers that were used would be either prohibitively expensive or they're like sold out and you couldn't get them. But it turned out neither of those things was true. It cost $1 million for one ship set of blades. The 3D printer cost $2 million, and they were in inventory. You could get them in like 2 weeks.
Right.
So we said, this is stupid. Buy the machine. Yep. Once we've made 2 engines, the machine will have paid for itself. And we'll get the blades faster than we could have gotten them out of the traditional supply chain. So the whole engine development is full of stories like that. The meta framework is to optimize for the pace of iteration. So every iteration has to be fast and cheap. And so we watch for what things are expensive and what things take a lot of time. And we try to kill those things out of the development program so that we can build things and break them and then iterate and build again. And so, but both on the engine, on the Overture airplane, you're going to find that our development looks a lot more like the spaceship Starship development. Like by the time we're testing, unit X plus 1 is already half built.
Well, it sounds like you're
and that's the way you build an engine and an airplane fast and cheap.
Right. Well, it sounds like you're on pace to prove quite a bit of people wrong on the engine development, because most folks always say that startups can never build an engine from scratch. So that's pretty impressive. So let's talk about the Overture.
We'll find out soon whether the skeptics are right. Like we don't have to wait long to settle the bet.
Yeah. So what about the are there what type of engineering challenges are left on the plane minus the engine?
Yeah. It's a lot of just like detailed engineering stuff. So we've got the configuration frozen, so we are on the airplane where the 777 was about 4.5 years before it carried passengers, from just a kind of engineering maturity perspective. And and so there are, so what we're doing is taking the high level configuration, and we've started on sort of the more detailed engineering for what will be the first pre-production prototype. And that effort's in full swing. And, we'll start building the first full scale airplane next year.
Got it.
Amazing. Let's talk about boomless cruise. Okay, so what does it actually take to design, quiet boom, right? You mentioned Mach 1.3, which is, sort of the upper limit of what you can get to get to that quiet boom, but talk a little bit about how it works functionally.
Yeah. So on a typical day, just to put the benefit in context here, a typical day, you'll be able to fly boomless at about 1.15 Mach. So on a good day, you can go up to 1.3, but 1.15 will be typical. And that's about 50% faster than the 737. So, does everyone want to go Mach 2? Sure. But boomless cruise gets you plus 50%. And the most amazing thing is just how easy it is. Like, people have talked for a long time about solving sonic boom, and it's like been, treated as this like boogeyman. And NASA's got this X-59 thing, which I think is designed to be hard, where they don't try to get rid of the boom. They try to dampen it out by making the airplane long and skinny. And it's this very like hard to build, hard to scale design. The thing is, like, I don't think it's even taxied yet. I think they did like an engine run, but because there's so many just issues with this very difficult design, and that thing will be able to go to 1.4. And it still makes a boom. It's just a quieter boom if you fly it, in a straight line. If you get off the straight line, then it's a loud boom again. But boomless cruise is a software fix. And it's about flying the airplane at the right speed and altitude, such that the boom makes a U-turn in the sky and never reaches the ground. And it turns out all you need is a computer, and you need like decently good, not perfect weather data. And so the way it works is the boom refracts. So let's remember that every waves refract. And what's refraction? Refraction means waves bend when they go through media where their speed changes. So you think of that experiment where you got a glass of water, you drop a pencil on it, the pencil looks broken. It's because the speed of light in water is not the same as the speed of light in air, and the light waves bend when they go into the water. Now, speed of sound's a wave. And it's the speed of sound varies with temperature. So the speed of sound is actually higher at the ground where it's warmer, and lower up high where it's colder. So and waves they refract towards low speed. So that means booms curl upward. It's convenient. And this is true in the first 36,000 feet of the atmosphere. So if you control the speed of the airplane carefully, you can control the angle at which the boom comes off the airplane. The slower you go, the more shallow the angle. The faster you go, the steeper the angle. So if you know the temperature gradient in today's atmosphere, which we've got weather balloons, we've got all that data, it's all publicly available, you can calculate with margin the fastest quiet speed, and you can have an autopilot mode that kind of just holds that speed. So this is a software fix. Sonic boom doesn't require some fancy, complicated, impossible airplane. It needs software.
So what you're saying is it's all about understanding the temperature and controlling speed, and it's not necessarily about flying the plane itself in some fancy way.
Right. I mean, it is about wind and temperature in the atmosphere, and all that data is out there. And then you can ironically use algorithms from computer gaming. You use ray tracing. Mm-hmm. And that tells you for the altitude you're at and the day you're flying on, here's the speed you can fly, such that the bottom of the U basically never touches ground.
On a more practical note, what does if I'm sitting here, I'm sitting here in an office in New York, what does a sonic boom sound like, right? So I've heard, I've seen Falcon 9, sort of the first stage of Falcon 9 return. And as it's returning, if you're close enough, it's you get a sonic boom right as it's about to land, and it's very loud, right? You can hear it very clearly. So what does that give us a little sense of, like, you have a plane flying at 36,000 feet. Like, what does the sonic boom sound like?
Yeah, the reentry on a Falcon 9 or on a Starship, super heavy, is kind of the worst case for a sonic boom, because basically they're flying right at the launch pad while they're transonic, right around the speed of sound. And at those speeds, most of the energy is projected directly forward, which means the boom's aimed right at the launch pad. And it's a fairly like blunt object, so it tends to be loud. But by the way, like nobody's hurt from those. Arguably they're cool. Would you want it in the middle of the night every night? Maybe not. So sonic boom. The best way to think of this in an airplane context is it's like the wake of a boat, and a big boat makes a big wake. However, the more distant the boat, the smaller the wake is by the time it gets to you, and wave energy intensity falls off with the square of distance. If you double the distance, you cut the intensity by a factor of 4. So if you're up at 60,000 feet with a relatively small airplane, I mean, we'll have to see what it sounds like when we fly it. But it's going to be, it'll be something you hear, but it's not going to break any windows. I think, and I've heard a whole bunch of booms, while I hang out with the boom team in the Mojave Desert, from other airplanes. And some of them kind of get your attention. It's like, yeah, okay, I don't think we should do that. Probably not during overnight, at least. Yeah. And there are others that sound like somebody dropped a book on the floor.
Sure.
And it's just no big deal. So they're not one size fits all.
So, you're taking a, pretty classic aerospace OEM approach, designing and selling the aircraft, not operating them. So I'm going to give you the probably easiest question I've asked up until now, which is why not control the entire stack, right? Like a vertically integrated airline. I mean, since you are, innovating in other ways, have you thought about, has it crossed your mind is all I'll ask.
Yeah, it was actually the original business plan.
I see. Okay.
Truth be told, the first thing I did was I wrote a business plan and did all the financial modeling for a convenience-oriented airline, something like what JSX is today. And I concluded there wasn't a very good competitive moat without the airplane being any different. So I said, okay, we should really make the airplane supersonic. And then along the way, what I realized was it was really foolish to take on 2 very difficult missions all at the same time. And it would be really helpful to have market validation from with airline orders in order to be able to get suppliers and investors on board. And then the other thing that surprised me along the way is that I think I had sort of mentally modeled airlines as stodgy and not innovative, and that's certainly true of some, but it's actually not true of all. And so I'll call out United here. I think is really just the most forward-leaning in the business, and Scott Kirby is a truly visionary CEO. At the same level as like a Juan Trippe or Howard Hughes, and so United was willing to put down a deposit on supersonic jets before we'd even flown the XB-1. So there's no need to build an airline. There are actually quite visionary airlines who are happy to work with us, and that greatly increases our odds of success.
What are the routes that you envision flying with Overture first?
Yeah, there's something like 300 city pairs. So it'll be up to that work economically. It'll be up to the airlines which ones to fly first. United sized their order for 15 overtures, around 13 for New York to London plus 2 spares. But the reality is the airplane could do far more than that. It'll be up to Scott and team at United where they want to start. My hope is that they do something other than what Concorde did, because that will help send the message that this is not Concorde 2.0. Supersonic's back and it's different this time.
Right. Now, you've raised hundreds of millions so far, but as you kind of alluded to in the past, oftentimes aerospace projects can go billions over budget. How much capital do you think you'll need to deliver your first plane?
So if Boeing or Airbus did this, it'd be $10 or $20 billion. And so we know we can't spend $10 or $20 billion on this. We just won't get it. So we put a lot of our energy into how do we develop faster and cheaper. And we did XB-1 for about an order of magnitude cheaper than any supersonic program ever before. And knowing what we know now, we probably could have cut that by another factor of 5. And so we have an effort internally that I call Project 10X, that maybe I should have called Project 100X, which is basically we expect to be 10X to 100X more productive than traditional players. And it's really possible. We did it on XB-1. And we're doubling down on that with Overture. And it's a combination of software, AI, small elite teams, and vertical integration that I think is the formula there that will allow us to do this for something more like $1 to $2 billion, which is an obtainable amount of money. And a $1 to $2 billion development cost. This will be great investor returns. 10 to 20, I think we just don't get done.
Yeah. I want to talk a little about a company called Aerion. So they were once considered a viable option in this space by some. They were backed by Bob Bass, billionaire based out of Texas, I believe it was. And they folded. Do you know what they got wrong? Do you have any thoughts or an assessment of that company?
Yeah, so first off, I have immense respect for anybody who has the courage to try this.
Right.
And so I was saddened when Aerion folded, but I wasn't surprised. Aerion was wrong strategy, executed wrongly. I'll break that down. Let's start with the wrong strategy, because I think even if they'd executed it perfectly, they wouldn't have succeeded. They said we're going to build a supersonic business jet, not a supersonic airliner. And it seems like it makes sense, right? Because business jets are for the people whose time is most valuable, who are most willing to save time. An airplane can be smaller and simpler, if it's going to carry 5 passengers and it's going to carry 50. So that seemed plausible. But the problem is 85% of private jet miles are over land. And so if you can't fly faster over land, 85% of the time there's no benefit. And there are a bunch of other downsides that trade with, increasing top speed. And so, okay, could they have changed the rules? Well, they certainly tried to. But if you're building a product for the 1% of the 1%, it's very difficult to get political support to change the rules. So Aerion banged their head against the regulatory wall, and and I think they got nothing other than a concussion. And then we're building an airliner. So one, we can give this to United. United doesn't need to fly it coast to coast. They can fly it transatlantic. They can fly it trans-Pacific. And it doesn't need to have a change in regulatory rules for it to have a market. And so that means instead of this really being a vanity market for the 1% of the 1%, even without a regulatory change, there's a market for 1,000 plus of these things for airlines. And then the second thing is, because this is an airline product, anybody can buy a ticket on it. And because it's going to be radically cheaper than Concorde to fly on, all of a sudden, it's politically safe to get behind it. So where Aerion failed legalizing supersonic flight over the land, we succeeded. And so we've blown open the door, and I think other people will do supersonic business jets because that door is blown open now regulatorily. So that was bad strategy. And bad execution. They made a mistake that I almost fell into. We lost our way on this a little bit, and we found our way out of it, which is that they hired a bunch of big aerospace people out of big companies that thought they knew how to do this, and they ran a Boeing-like development playbook. And what that means is they blew through $1 billion of Bob Bass's money while not having built and flown anything. And so they didn't do, they did that thing where they didn't build any prototypes. They just built wind tunnel models. And so I think our regulatory victory here depended on, one, the fact that we're a airliner that anybody can buy a ticket on, that anybody can aspire to be part of, that it's easier for politicians to get behind, on one hand. On the other hand, our capabilities, like with Boomless Cruise, weren't theoretical paper studies. We went and did it. We did it 6 times. And I think that was essential. And moreover, by going and building and flying an airplane, we learned a bunch of stuff. Like if, people look at XB1 and they see a beautiful airplane, I look at XB1 and I say, oh boy, we wouldn't do it that way again. Because we learned so much. And I think that's really necessary. And, and Aerion was going to go straight into a certification program for a Part 25 supersonic transport, having been the very first hardware the company ever built. Whew, boy, that's tough.
Yeah. What does the next phase of competition look like? I mean, now that you have this, order out for this repeal, do you suspect other companies start to kind of come out of this over the next few years? Or do you think look, this is just such a challenging problem that, anyone who goes out and tries to build a supersonic jet is going to really need some capital behind them from day one.
If I were so let's look at the incumbents on the airliner side. If I'm Boeing or Airbus, I think I watch the space and I look for the right moment to buy Boom. If I'm Gulfstream or Bombardier or Dassault, I think I give some real thought to I should launch a supersonic business jet. If I'm an entrepreneur, I think Boom is years ahead on building an airliner. I probably, I probably shouldn't try to catch up with that and compete, but maybe I could beat Gulfstream and Bombardier. Maybe I should start a supersonic business jet company. So, I mean, we'll have to see, but I think there's going to be competition. I think there'll be other entrants.
Right.
I'll be hugely disappointed if there aren't.
Right. Now, I want to switch gears away from civilian for a second. You've recently partnered with Northrop Grumman on a military variant of Overture. What does that mean?
So we've been working with Northrop to kind of explore what use cases really make sense for kind of an Overture derivative for defense and government use. And what we've learned is that there are really two things that Overture can really help with. And let me tell you what it can't help with. It's not a good spy plane. There is a very narrow scenario where Overture can get over a target when the satellites have been taken out. But then it can't loiter very long. And then hopefully there's a replacement satellite in orbit pretty quickly. It's like, you have to really squint to see where that's useful. It's not a good command and control airplane, similar because it doesn't loiter. It can get there really fast, but it can't hang on for very long. It's not what it's designed for. So it's really transport that Overture is good at. And first and foremost, it's VIP transport. So we'd love to replace the C-32s that carry around our VIPs today. I think if you're willing to think differently about Air Force One, and it's a flying motorcade, not one flying tank, I think you could do a supersonic Air Force One. I don't think that's where you start. I think it's where you end up. And then I think there's high value cargo. How quickly can we get a logistics package to Taiwan or to Guam? How quickly can we evacuate a wounded soldier to life-saving medical care? I think those are some use cases there that will really help. But I think the most important, so Overture will probably sell a dozen of these things to the government, but not 100. And I think the most important thing we're going to do defense-wise, which I didn't appreciate when we inked the deal with Northrop, is actually its defense industrial base. So you've probably heard the quip that in a shooting war with China, we'd run out of cruise missiles in 8 days, and then it takes 2 years to get another one. It goes, and probably many people listening to this have read or at least heard of Freedom's Forge, so they know the story of how the U.S. won World War II industrially. And it's this idea of, we didn't go in with a defense industrial base. We went in with a flexible commercial industrial base that was the envy of the world. And Ford, Boeing, Douglas all pivoted from building civil products to defense products, and we outproduced the Nazis and we won the war. And but today, the best factories in the world are in China. And I think that's super, super scary. And the tooling engineers, if you throw a baseball in China, you hit a tooling engineer. It's really hard to find one here. And so, everything we are doing industrially is designed to be flexible industrial base. So with minimal changes, and we try to do as much software-defined manufacturing as we can flip from building supersonic airliner engines to fighter engines or bomber engines or cruise missile engines. Many times that can actually be a software change in the factory with very little or no hard tooling. And similar for vehicle assembly, we're looking at, over time investing more in automation and having this be a tooling light kind of software defined manufacturing approach. So if worse comes to worse, we'll stop building airliners and we'll start building whatever the Defense Department needs. And I think we'll be able to get there faster than a lot of the legacy players who have sort of gotten fat, dumb, and happy on cost plus government contracts where there's no incentive except to be. I mean, these cost plus contracts are the stupidest thing. You're incentivized to use more time and use more money. So I think we need a commercial industrial base that can pivot.
We just got to lower the idiot and slacker index. What is? I mean, we're working on that in a pretty serious way. Like I could tell stories over and over again.
like it takes, if you want to get a new turbine blade out of the legacy supply chain, if you're with a production type process, you're lucky to get it in 18 months. And we think we might have found a way to do it in a couple of weeks.
Yeah.
So we're working on stuff like that.
By your comments on the industrial base, is that sort of hinting a little bit about your own personal mission behind Boom?
Say more.
So just like, from when you started the company, right? Like what was there's I want to solve this problem, but like, is there anything in there on a deeper level that like drives you to keep going?
Yeah.
You didn't think I was going to get existential on you like that.
Is very much. Yeah, no, I actually really appreciate it. I mean, I have this essay I wrote in 2014 that maybe I should like republish, called "I Feel the Need for Speed," and but it wasn't about going fast, like Top Gun style. It was about speed is about removing the barrier to human connection. It's about connecting across distances, about connecting across cultures, and I think it's really hard to go to war with somebody you've broken bread with. And, the world I want to live in is one where our children have friends from other cultures and other continents that they've spent time in the same room with. And to do that, we need flights that are faster, more affordable, more convenient, more sustainable. We actually have not had a world war since the dawn of the jet age. And I don't think, jets are the whole story there, but I don't think they're irrelevant either. And as I watch, and yet I think I also, 10 years ago, I was much more naive about the world, because I sort of grown up in the post-Cold War era, and I sort of thought that the era of evil powers was like largely behind us. And, and I think what all of us have seen lately, whether we're talking about China, or we're talking about Ukraine, is the world is not as safe as I thought it was when I grew up. And, ultimately, I want to live in a world where we don't have to fight China, where we don't have to fight Russia, where we've found a way to bring freedom, individual rights, democracy to other countries. Because, by the way, if we can do that, we never go to war with other democracies. We only go to war with dictatorships, right? And so if we can eliminate dictatorship and export the ideas of the founding fathers, then we don't, then we can have economic competition, and that's just fun, but it's not scary. But we're in a world now where we've let dictatorships, boy, it feels like they're precursor to World War II. We've let a couple dictatorships, primarily China, get really powerful, and that means there's a different kind of competition and a far scarier kind of competition. I'd rather it never come to blows, but if it does, we got to win. And so I feel very motivated to do everything I can. Others are building weapons, but I want to be what Ford or Boeing was pre-World War II, where if I ever need to, I can pivot on a dime and let's make sure everybody knows, because that's what keeps us safe.
Yeah. I think super well said, and I'm glad I asked that question. 20 to 30 years from now, what does Boom look like?
So here's my big civil dream. Supersonic flight is boring. Nobody thinks it's special anymore. It's just how we all travel. And in fact, we've pushed beyond supersonic. I did a little calculation for fun on what is the maximum practical speed. And it turns out it's really limited by two things. It's limited by the top G-force that passengers are willing to tolerate, and it's limited by the radius of Earth. And so sort of imagine you're doing the longest possible flight on a planet of Earth's size, which means you're going to the direct opposite side of the planet, and you're willing to accelerate continuously at sort of the same acceleration profile you'd have at takeoff on an airliner. So imagine you sort of accelerate at roughly 0.2 Gs, a quarter of the way around the planet, and then the airplane flips around and it decelerates at 0.2 Gs for the rest of the flight. And so it's a fun little spreadsheet model to say, okay, well, what's your peak speed in such a flight? And it turns out it's very nearly orbital velocity. It's like right around Mach 21. And so do you actually end up with a Mach 21 vehicle in 20 or 30 years. I don't know. Maybe that's ambitious. That's
you got a rocket on your hands.
But yeah, but I don't really think there's by the way, and the flight would be something like an hour 45.
Yeah. Well, we talked about Starship, right? Like, there's probably some type of scenario, and I don't know how far into the future where there is some type of, and people have talked about this ad nauseum in the space industry about some type of hypersonic point-to-point travel with Starship. I don't know how realistic that is in our lifetime, but that's a different flight trajectory.
It's a different flight trajectory. It's a very, very different passenger experience. It's lots of G's followed by none at all, which I think some people would consider a feature, others would consider a bug. I think the tell on this is really to listen to what Elon says. And Elon can't shut up about his idea for a supersonic jet. And so I think if he thought Starship was going to make supersonic irrelevant, he would be less excited about a supersonic jet.
Right. Well, Blake, pleasure to have you on the show, and especially right after the announcement on the order. So really appreciate you being on the show. You're obviously working on an amazing piece of technology, and really excited to see how it develops from here on out. And then once you fire Symphony, let's get you back on the show.
I'm looking forward to it. Maybe we should come to the firing and we can record with a little bit of engine noise in the background.
I'd love that. Blake, thanks so much. Till next time.
Thanks, Mo. I appreciate you.